Okay, so here we go again. Back with Learning with D. Get with us at Facebook, Instagram. So what we're talking about, the laws of indices. Previously, what we did was look at the other laws. Now we're going to be looking at these three laws. So let's get started. If I have 1 over 4 squared, what, according to this rule, I'm going to end up with is 4 to the negative 2. Because in this case, A is 4, right here. Your A is your base. And right here, your 2 is your power, which is your x, okay? And so what we're saying is 1 over a to the x is equal to a to the minus x. So let's look at this a little differently. Remember our very first rule. What did it say? It says a to the 0 is equal to 1. So wherever I see 1, I really and truly could change that around, can't I? So if I have 1 over 4 squared, I could kind of say this is 4 to the 0 power over 4 squared, can't I? Because this is really 1 right here. This is really just 1. So I didn't change the problem. So then, according to my other rule, I had a to the x divided by a to the y is equal to a to the x minus y. So this would then be 4 to the 0 minus 2, wouldn't it? And that would just be 4 to the minus 2. Okay? So basically, this is just one way of looking at it, kind of like if you're being asked to prove it. The truth of the matter is, this is the way the rule works. So another example, if I had 1 over 2 to the 5th power, this is the same thing as 2 to the minus 5. So how about this? How about if I had, let's say, 2 over 3 cubed? Well, what I would have to realize then is that this would become, we have to look at this in this manner. This is 2 multiplied by 1 over 3 cubed. Hence, this is 2 multiplied by 3 to the minus 3. Why? Because if I look at this part right here, I have 1 over a to the x, and this is going to be equal to a to the minus x. So when I have 1 over 3 cubed, it will be 3 to the minus 3. But this is being multiplied by 2. So if I wanted to leave this in this manner, meaning just apply the rule, then it should be 2 times 3 to the minus 3. Of course, if you weren't using the law, what you would just have is 2 over 27. But for now, I'm just showing you how to utilize the laws that we have. There are going to be instances in which you end up utilizing the law. Matter of fact, let's look at one. What then if I had a case like this? What if I had 4 divided by, let's say, a cubed? This would then be 4 multiplied by a to the minus 3. That would be my answer. How would I get that? All right, 4 over a cubed would be the same as 4 multiplied by 1 over a cubed which would be the same as 4 multiplied by a to the minus 3, which is 4a to the minus 3 power, which is what I have here. Now, I want to make something clear. This rule, 1 over a to the x is equal to a to the minus x. You might look at this and say, well, this is always going to be positive. Not the case. All this is saying is whatever the power is, right? If it's positive, it will become negative. If it's negative, it will become positive. What do you mean? Okay. What if I had 1 over a to the minus 4? That would then become a to the minus of minus 4. Why? Because in this case, your x is the entire minus 4. So when I come up here and I do a to the minus x, I have to do minus whatever that is. This then becomes a to the positive 4, except we don't write positive 4. We're just going to write a to the 4th power. So whatever the sign is for the power, if it's in a denominator, it will become positive when you put it in the numerator. Okay, so here's another example. What if I had 3 over, let's say, m to the minus 2 power? What this is 3 multiplied by 1 over m to the minus 2. This then becomes 3 multiplied by m to the minus 2. And this becomes 3m squared. Minus or minus 2 becomes just a positive 2. And 3 times m squared is just 3m squared. So, moral of the story here, you have a to the x power. If it's in the denominator, you're going to take it up. It becomes a to the minus x. But if x is negative down here, this does not change. It'll just become a to the negative, whatever x is. So if x is negative, it'll become a to the negative of a negative. One more example. If I had 1 over y to the 3rd, this will become y to the minus 3. But if I had 1 over x to the minus 5, this will become 1. Sorry. This will become x to the positive 5. And how I got that? I did x to the minus 5. This here is what x is. What your x is, your exponent, right? I got to take the negative of it, right? So negative of a negative becomes a positive. X to the 5th power. Let's move on to this bad boy. What if I had 2 to the 3rd power, and then this was squared? Remember, in one of the earlier videos, we had 2 to the 3rd multiplied by 2 squared. And what we did according to our rule was add these powers, right? So we ended up with 2 to the 5th power, right? Our rule then said a to the x multiplied by a to the y is equal to a to the x plus y. This is a different case. You're not multiplying anything here. What we're doing here is we're saying we're going to have something, and then that is raised to yet another power. So according to my rule, what I'm going to have is 2 to the 3 multiplied by 2, which is 2 to the 6th power. Well, that should make perfect sense to us, right? Why should it make perfect sense to us? First of all, we could check it, right? We could check it 2 ways. Here's the first way we're going to check it. What we're going to do is we're going to say, okay, what is 2 to the third? Well, 2 to the third is 2 multiplied by 2 multiplied by 2. 2 times 2 is 4. 4 times 2 is 8. So this is 8 squared. And then this is squared. So 8 squared is actually 64. Okay. So what is 2 to the 6? Well, 2 to the 6 is 2, times 2, times 2, times 2, times 2, times 2, until I have 6 2's. 1, 2, 3, 4, 5, 6. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So it's correct, right? So this is one way we could have checked it, right? We could have just done what's inside the brackets first. We found that to be 8, and then we square that, okay? That's one way we could have done it. Here's another way, right? Going back to what we've learned before. What we learned before about what power is, right? It's very simple. What this is whatever is inside this bracket, this says to square it. So I have 2 to the third multiplied by 2 to the third. So I have one instance of 2 to the third, a second instance of 2 to the third multiplied by each other. That's the essence of squaring. So I didn't evaluate what's inside the bracket yet. I'm just squaring them. Now, when I get here, according to my rule, one of my first laws, at this point, I'm multiplying now. I no longer have an exponent being applied to another exponent. I now have a simple, straightforward multiplication with the same base. So what do? I add the powers. So I get 2 to the 3 plus 3. Hence, I get 2 to the 6th power. So that's another way I could have checked it. Bottom line, what this rule is telling us is if I have 4 squared and then I raise this to the 4th power, this then becomes 4 to 2 times 4, which is 4 to the 6th power. That's what this rule is telling us. Okay. Now, let's look at this rule. If I have the square root of 25, what this is saying is that this is the same thing as 25 raised to the 1/2 power. Now, to verify this, you're going to have to utilize your calculator. Okay, so you want to grab your calculator, you want to plug in 25, and you want to raise it to the 1/2 power, and you will get 5. In both cases, you will get 5. So this rule basically is simply saying whatever is in this root sign. So it could be a third root, which is a cube root, right? So I could have the cube root of, let's say, 27. And this is equal to 27 to the 1/3 power. That's all this is saying. Cube root of 27 is equal to 27 to the 1/3 power. You plug this into your calculator, you should get 3. And we know the cube root of 27 is 3. By the way, how do we know that? Because cube root means something multiplied by itself will give us this number. 3 times 3 is 9, times 3 is 27. So, well, again, you have your calculator to verify that in fact, these are the same thing. So that's all this rule is set out to demonstrate. Now, what's going on here is that these rules, all these rules that I've shown you, they work backwards as well. What do I mean? Well, if I happen to give you a problem that says, let's say 49 to the 1/2 power, you have to remember that's the same thing as the square root of 49. See, it works that way as well. The way I taught you, the way I demonstrated to you, we went from left to right, but it works that way. That's what the equal sign means. Okay, so 49 to the 1/2 is 7. 7 times 7 is 49. By the way, it's plus or minus 7. Okay, so you have to be able to recognize that. So again, if I gave to you, let's say 100 to the 1/2, what you should be thinking is that this is the same thing as the square root of 100. Okay, that will give you your answer. That's working backwards. Similarly here, right? Again, this you will find much use for as you work problems. This one not so much, but you still have to understand that it works both ways, right? So if I give you, let's say, 2 to the 5th power, and you find it convenient, okay, let's say 15th power, you find it convenient. This is the same thing as 2 to the 3rd raised to the 5th power. It's also the same thing as 2 to the 5th raised to the 3rd power, right? And you're gonna see instances where that is convenient, right? Again, similarly here, this also works this way, okay? What if I have 4 to the minus 4 power? Well, that's the same thing as 1 over 4 to the 4th power, okay? Similarly, if I have 4 squared, that's the same thing as 1 over 4 to the minus 2. Now, practice and practice and practicing will help us to get to a point where we see where we want to do it this way, or this way, or this way, or this way, right? And we're going to find problems, and more problems are going to come along when we subscribe and sign up for one of the classes, okay? What I'm going to do is I'm going to throw in a couple of problems. I'm going to create a video and demonstrate a couple of problems that utilize some of these laws in both directions. And I'm going to post it up, okay? But in the meantime, what I need you to do is I need you to hit the thumbs up button. Hopefully this helped. I need you to subscribe, of course, so you can find out when I put up new videos, and feel free to put in the comments any topic that you might want me to cover, and I'll see what I can do. Hit the subscribe button up here. Take a look at the previous videos, all right? And I hope this helped.